Huygens principle of wave propagation, when applied to a source which is allowed to pass through a narrow slit, will give rise to some contradictions. Ideally, in ray optics, we see that if source is allowed to pass through any geometric body, it should give a geometrical shadow region on the screen. So here in the diagram, as you see, we have a point source which is giving a spherical wavefront. On that wavefront, we can consider all these dots to be sources of secondary wavelets, and the next tangential point of all those wavefront is the new position of the wavefront in later time. This, when allowed to pass through slit, gives illuminated portion on the screen which is in the shade red, and black on both sides is the geometrical shadow region. But it was not observed in practice. In practice, what was observed was, in geometrical shadow also there is some illumination present, and in the illuminated zone there was redistribution of intensity of light, and instead of a constant intensity we get diffraction pattern. This could not be explained by Huygens principle. So noticeably there were two drawbacks of Huygens principle. First one, disregard to the overlap of wave in the region of geometric shadow. Fresnel's introduced the idea of interference of these secondary wavelets, which justified the presence of light in the geometric shadow region. So you see here the blue cross are indicator of the area which was eliminated or not considered by Huygens theory. The second problem was, he ignored the wavefront formed by backward traveling waves. So it only considered the forward movement of the wavefront. For this, Fresnel, with the help of Kirchhoff's mathematical formulation, introduced the term called as obliquity factor, which said that uh, it is proportional to 1 plus cos of theta, theta being the angle made with the x-axis. So in forward direction that angle would be 0, so intensity would be maximum. If and when the theta is 180 degree, that is the backward traveling wave, as cos of 180 is minus 1, there would be no light which will be going backward. So the intensity of light or amplitude will keep on reducing as the direction moves away from 0 degree, which was in justification to what we observed in practice.